Hello everyone. I welcome you all again to my channel, The Data Dialogue, and this is Talha. So today we're going to talk about again as we'll just continue the previous session of SQL and we'll talk more about SQL. So this is SQL session 2. In this we'll try to understand a little bit more about constraints, maybe joins, unions, some more queries, but it's going to be simple. So it's not going to be very complex even today. The point is just to continue from the previous session. So I really hope that you guys installed MySQL after the previous session. You guys installed PopSQL after the previous session. And if you did, then that's amazing. So we can just continue and take it from there. So what is Data Dialogue? It's a blog and it's basically a website that I'm trying to create, and it's the goal is to uh, just make sure that you guys understand the data terms. It really the point is to make it very easy for you to start your data journey, and then you can always upskill, right? There's no limit to how well you can get, but my goal and my aim is to help you in this field and to give you a heads up. All right, so this is episode 2 for Introduction to SQL. So before we start, I'd like to talk about the previous session in what we discussed. So what we discussed was in the previous session, we talked about basically we discussed what's a database, right? A database is basically a collection of related information. So you have different tables. These tables are related to each other by different columns, which we call keys. I'll talk about that as well. Then we talked about what databases are stored in various shapes and forms, right? They could be on a paper, on a piece of paper, in your mind, on a notebook, on your hand. But the best way to store is if you store that in computers. And how do you access these databases? How do you manage them? How do you store, retrieve, and manipulate the data? You use a system which is called DBMS, Database Management System. And for relational databases, you use RDBMS, which is called Relational Database Management System. Now they allow you to perform CRUD operations, which is create, it's read, update, and delete, and other administrative tasks as well. And then we also discussed about different types of databases. So we have relational, we have non-relational, and then again, as I already mentioned, relational databases would use RDBMS, and in relational databases we use SQL to retrieve the data stored in tables, or to use that data, or just to create the data in those tables, right? And then non-relational databases, they basically use NoSQL, and their data storage sometimes it's key value pairs, it could be JSON graphs, etc. Then just to give you a quick recap of tables, records, and attributes, right? So what's a table, and what's so let's say we have this employee table, right? Now table is nothing but let's say a combination of rows, the horizontal ones, and columns. So what's a row, if we and what's a column? So if you look at these vertical ones, we discussed that these are columns. We also call them records, sorry, we also call them attributes. We also call them fields and columns. You'll only hear these three names, right? It's column, it's attribute, or it's a field. Then we have these horizontal ones, which we call rows, records, or we can sometimes also call them events, right? So this is what we have. This is basically a table. Now, in when we were talking about Power BI, we talked about joins, right? So I just want to have quickly go through what joins really are. So we have four kind of joins. Oh man, all every time there's this. How do I hide this? Yeah. So there are four type of joins. For first, what is a join? It's basically a join is a term literally in English. You mean join when you join different things, right? So when you talk about databases and tables, join means when you're trying to combine or retrieve information. Just remember, you're retrieving information from different tables, some information from employee table, other information from department table, then other information, let's say, from the client's table. So you have to somehow combine these tables to retrieve that information for, let's say, one employee or multiple employees, right? So for that we use joins. Now what kind of joins do we have? We have left join, we have right join, we have inner join, we have full outer join. So in left join, we discussed that it returns all the records from the left table. By left table, I mean the first table that we use in our query, and only the matching records from the right table, which is the second record that we use in our query. I'll talk about this later in our session today. Then we have a right join. So in right join, we return, it's entirely opposite of left join. So you return everything that's there in the right table, but only matching records from the left table, which is the first table in this case. Inner join will return all the common records in both the tables. So if you go for any record, it has to exist in both tables, otherwise it will not return that. So it will only return the common values that are in both the tables. And outer join is exactly the opposite. So it opposite of inner join, it does not care if it exists in one table or not, or and also the other table. It will return regardless of whether or not it exists in both the tables. So let's say you have an employee name, right? So let's say if employee IDs, and then you have b- department IDs, right? And some of the employees don't belong to a department. So if you were using a inner join, the department IDs will not be returned, right? But in this case, even if an employee does not belong to a department, if you join these two tables, it will be returned. I know this might not make a lot of sense to you because we discussed a lot this in a lot of details in previous sessions, but we'll discuss more when we're doing the query itself. So what's the main difference between joins? It's just inclusion of non-matched rows. So do you define that non-matching rows should appear in your query? That's basically the difference. So now we have keys. We also talk about keys. Now what are keys? Keys are nothing there but fields, right? They're kind of now you know what are fields? They're columns. So we have two kind of columns. We have primary keys, and then your foreign keys. We also discussed this in the previous session. Now, primary keys is a unique identifier of any record in a table, right? By unique, I mean no two rows or no two records can have the same primary key. One primary key can only exist for one record. For example, if you're talking about data professionals ID, right? So let's say my ID is one, and let's say someone else's ID is two. No one else in that database can have the data person ID is equal to one because that's mine and that's unique. And again, it can never have duplicates as well. Remember that, because primary key cannot have duplicates. It cannot have it has to be unique, and one table can only have one primary key. So you can't say, I mean, in fact, in a table you can have so many unique identifiers. For example, you have my mobile number, you'll have my email ID, right? They're also unique identifiers, right? But when you talk about primary key in one table, you can only have one column as a primary key. So if you look at this, for example, this is employee ID, right? Now we have very unique employee IDs 1, 2, 3, 4, and 5, and this is a primary key. Now you see, we have two Johns. We have John in the HR, we have another John in the HR, which could not be uncommon. You can have same people with the same names, I mean, different people with the same name in the same department, but how would you differentiate them? By the primary key. Now that's a unique identifier, right? So this is what primary key means. Other examples would be, let's say, some emails address, your phone numbers, your passport numbers. No two-person in the world can have same phone number or passport or email address. So now if you look at this key, now this is something which is, it does not mean anything in real life, right? 1, 2, 3, 4, 5, they're just numbers. So we call these surrogate keys, the primary keys that don't have any value in real life. Then we have these email addresses, numbers, and passports. These have real values in life, right? So we call them natural key. Now, now this foreign keys. Let's move to the topic of foreign keys. I have S in bracket. Now, if you remember, we said in one table there could only be one primary key, right? But for foreign keys, we can have multiple foreign keys in the same table. What is a foreign key? It's an attribute, by attribute, or a set of attributes, I mean columns, in one table that refers to primary key of another table. Let me explain that to you. Let's say we have employees table, we have department table. We have department ID. This is the primary key of department table, right? They are unique and they are not duplicated. So 1, 2, 3, 4, and they are not null. So each department is identified by their number. Then this is a primary key. But if you notice, you also have department ID in the employees table. And in this case, you can see there are some duplicates, 1 and 1. Why? Because this in this table, employee ID is the primary key, department ID is foreign key, which is the primary key of department table. So foreign key basically is used to reference. So if you want to see John belongs to which department one, they want to know more about the details of this department, you'll go to the department table and you'll see that John belongs to HR. And now this is when also joins will come in handy, right? So when you're joining, you join on something which is common between these tables. So let's say if you wanted to join these two tables, what would we use? We're going to use department ID, because that's the common thing between these two tables. Now let's say in the department table, I want to know, okay, who's the lead of this department, right? Who's the lead of HR? So I say it's 5. Who's 5? 5 is Alice, right? 5 is Alice, and Alice is the lead. Now this department lead ID, this is basically a foreign key in this table, but it's the primary key of the employees table, right? So I hope this makes sense to you, the difference between primary and foreign keys, and they're very important. So if you don't have, I mean, you need to have foreign keys and primary keys when you're creating tables, and when you're creating a very nice data model for your data analytics or your transactional purposes. So this is something that you'll always need to care about. I've seen so many people who get into the field of data who have no knowledge of the databases, how they're connected, what a relational database is, what are keys, right? And they just start working on SQL. Well, it's nice to just start and get right into it, but you need to know the basics, how, what basically these joins mean, what are the keys, right? What's foreign key, what's primary key. So now that we have understood this, let's move to what's composite keys. I'll talk that in this session later. So now in this in this we'll start with understanding some constraints. So we'll understand what unique means, what auto increment means, what not null means, and what default means. So let's just get right into it. So if you remember in the previous session, we had this is what we had done, right? So in the previous session, what we did was we basically worked on. I'll just try to zoom in over here. Yeah, I hope you all guys can see this. So what we did was we created an employee table with an employee ID, first name, last name, birth date. Wait, my bad. This is the wrong one. This is something else. Sorry. Yeah, this is what we had done. We created a student table with the student ID, their name, and their major. And then we wanted student ID to be a primary key, so we defined that this has to be primary key. And if you remember, what is this? These are basically data types that we need to assign to each and every field. For example, if let's say we had a GPA field over here, right? So let's say if we had GPA, what would the data type be? It's either int. No, sorry, it's going to be float. Why? Because this is will going to be it's going to be a decimal number. Primary key will not be decimal. GPA will be decimal, and we can not have, let's say, more than 3 digits for GPA. So these are the data types that we'll use. This is the name of the field that you want to create. And once you create this, we can use the describe function to basically understand or see what that table is about. So in this, you can see over here that we have student ID. So we have the fields, we have their types, we have the key. So this one is a primary key, and this cannot have null. So primary key cannot have null. That's by default, right? And then we talk about, and then what we did was we added values into this table. So we added all these values, all these people into the table. There's two ways you can add. You can either just use the function value. So you use insert into which table, insert into what table, student. What values do you want to insert? Now you might think, why am I writing in this order? So if you go back to the table, the first is, you see, one, student ID. So student ID is one. Then the name, that's the second input of the argument. Then major, that's the third one. But what if you didn't want to have major for a particular person, right? What would you do then? So what you'll do is you'll just use this function, insert into, and you'll define the columns that you want to insert the values in. So student ID and name. So you'll just add the ID and the name. That's it, right? And then we also talked about how we could update different records. So if you want to update, let's say, so we wanted to update the Ronaldo, right? So what we did was we say update the table which is called student, and the new name I want to be Johnny. So set name is Johnny. And remember, whenever you're writing text, it needs to be in these commas, right? And then where student ID is equal to 1. So 1 is the student ID of this person, right? And I of Ronaldo, and I want to replace Ronaldo's name with Johnny. So this is the function that I'll write. And then that's all what we did in the last one. So now in this, I want to talk about constraints that we just discussed. So what are constraints? Now, if you notice over here, I am creating a primary key, and I have to, in each and every row, right? I have in each and while inserting each and every record, I have to mention the primary key. And you can see they're 1, 2, 3, 4, 5. They just auto increment. What if I could just automate this thing, right? What if I didn't have to write this? And what if I would just let this DBMS, RDBMS decide that, hey, why not you add these keys for me and just don't bother me with this, right? So let me just create another table over here. So I'll call the student 2, right? So what you can do is student ID, integer, primary key, and I'll say, hey, make this auto increment, right? Make this auto increment for me so that I don't have to do it myself every time. And I press Control Enter. What does it say? Yeah, I think this is extra. Yep. So now what I can do is I can just I can just copy this as well over here. So we talked that, we also discussed that select is the statement you use. You can say, show me all the fields, right? So you're not choosing any field, all the fields from student to table. That's what we just created. So if you now, there's no record because we have not added anything in this, right? So what we'll do is we'll just again copy this real quick and we'll paste this over here. And I'll just call them all student 2. So now I will just add all these values. So now what I'll do is I just mentioned that I don't want to add primary key. So what I'll do is so I also talked how we could, if we just want to have particular fields that we want to add values into, this is what we do. So what I'll do is I'll just use the name, I'll use the major, that's it. Because I don't want to have the primary key. So if this is not making sense, please add that in the comment. Let's remove this from here, right? And then, so I don't want primary keys, right? That's what we said, because it's the system is going to take care of that. The DBMS is going to take care of that. So now I'll press Control Enter, Control Enter, Control Enter, Control Enter. What's happening over here? What's it saying? Wrong column or wrong row. Wait a second. All right. I'll just ignore that. Oh yeah, sorry, my bad. I'm so stupid. I did not mention the majors data. All right. So now let's see select from student 2 once more. And you see we have all this data over here, right? You can see we have all these values that we have added, and now you can see if you notice, I did not mention the primary key over here as I did in the last time, right? I'm just choosing that, hey, I want to add the name, I want to add the major, I don't want to add the primary key, because I'm telling you, SQL server, to add the primary key yourself and auto increment that. By auto increment, it means that keep increasing the number. So first you add 1, then you add 2, so you keep incrementing that by the order of 1. So 1, 2, 3, 4, 5, 6, 7, 8, and so on. And you can see that over here it has worked, right? So you don't have to really add that. This is a constraint that you can use while creating your databases, while creating your tables, and it will always and always help you, because it will really reduce the time that it takes you, to create the tables and to add all these values. Now let's talk about one more thing over here. Now we know that no person, no student can be without a name, right? There can be no student without a name, and there could be cases. Let's say if I had added null over here, right? So if I had null over here, show null here in this case, and that doesn't make sense. There could be no one without a name. I mean, it's not Game of Thrones, right? Where there's a person with no name. So with that was person with no face. I don't remember, anyways. So now what I can do is, let me define one more thing, which is I'm telling it that, hey, when you create this table, make sure that this field cannot be null, right? It cannot be null. There has to be some value in this. So let's try that real quick. So let me just drop this table once more. Let me create this table over here and see. Now I've added null. I'll just run this and you can see what it says over here. It says that name cannot be null, because I defined that you cannot have null over here. So this is how you control the constraints, and you have to be very careful with this, because some fields cannot have null values. For example, someone has to have, let's say, their phone number. That's the definition of a database. You require their phone numbers, you require their email addresses. So it's up to you if you make them optional or if you make them compulsory. Also, let's say if I don't enter the let me just drop this again. Let's say I don't enter, there's some new student who have not decided their major yet, and you just want the database to define that for you and just say that, hey, if someone has no value or they have no majors, why do you not just call it undecided? Yeah, is this how you spell undecided? Undecided, yeah. So if there's nothing in the major for a person, let's call it undecided. So I'll press Control Enter. It's created. Let's see what it says. It will be empty. Yeah. So now in this case, what I'll do is I'll just call it null. Is null. So null. I added this null over here. Now what I'll do is I'll go and select from student two. Wait, my bad. As usual. So in this case, what I've really done is I have actually defined. Wait a second. Student does not exist. Yeah. What I've done over here is this name. Yeah, how about I just add a name? Yeah, right. I've added the name. I'm not mentioning major. I'm just mentioning the name. And now if you go and select, you see over here it says undecided. Well, that was a little embarrassing. I need to get into practice. So Johnny, I said just Johnny. The name of the person is Johnny. I don't know their majors, so let's just call that undecided. And how do you do that? Use the function called default. Similarly, use not null, use auto increment. So these are basically different constants that you can use while creating a database. All right. So now what I want to do is, so this is a database that I have created actually, and I won't create that again in front of you because I already have done that. So this is what we're going to talk about in this session. We have an employee table, we have a client table, a branch supplier, a branch, and works with. So in employee table we have the employee IDs, their first name, last name, birth date, sex or gender, their salaries. This is the primary key, and these two are the foreign keys. So super ID is basically, it's basically nothing but it's coming from the branch. It's a supervisor ID, right? So this supervisor ID it comes from the same table itself and says that, hey, who is the supervisor of these persons? So let's say David Wallace has a supervisor of null because this guy does not have a supervisor, he's a supervisor himself. So Jan Levinson has a supervisor whose ID is 100, so it's David Wallace is the supervisor of John Levinson. Then similarly, we have a branch ID that's coming from the branch table, right? So let's say David belongs to the branch called corporate, and Michael Scott belongs to the branch Scranton, right? So this is also foreign key, which is a primary key of sorry, my mouse was on my pointer was on a different screen. Now this is a foreign key, which is a primary key of the branch table. Similarly, then we have a client table. So these are the client IDs which are unique. It's a primary key, their client name, and then branch ID. Now, what does this mean? It means that this client belongs to this branch. So Dunmore High School is being taken care of Scranton branch. So the employees who are in the Scranton branch, this number two, right? They are managing the client who is Dunmore High School. Then there's branch supplier. So we have branch ID, we have supplier name, and then you have supply type. Now in this case, one branch can have multiple suppliers for different products, right? There could be a supplier for pencils, then another one for sharpeners, then for printers, then for scanning, and so on and so forth. So it means that you will have if you were to have only branch ID, you'll have multiple instances of the same branch, right? Let's say if one branch has 10 suppliers, you'll have the same ID 10 times, which is not unique anymore. But one branch can only have one supplier for what? For one thing. So one branch will not have two suppliers for pencils. So what we are doing is we are trying to combine these two keys, these two fields, so branch ID plus supplier name, these two together are unique. Now supplier itself is not unique because they exist twice. So Uniball is basically providing writing utensils to branch ID 2, which is Scranton. They're also providing to branch ID 3, which is Stamford. But If we combine these two, so branch ID 2 plus hammer mill, this record will only exist once in this entire table, right? So now this is unique. This is called a composite key. So when you don't have a unique primary key, you combine different fields or different columns or different attributes to create a key that is unique, and then you call that primary key. So I just wanted to give you a high level insights of what this table is about that we're going to be working on. So now let's get back to pop SQL. Yeah, here we are. So let's I have created this over here. Where is it? I keep forgetting where my pointer is. So this, I just created that over here. I'll just walk you real quick through it what I've done, because I just want to introduce you the concept of foreign key. We all understand what this is. We have a primary key, so use the type, data type, then the type of the key. So this is varchar, this is date. Again, all of the salary is integer, supervisor ID is integer, branch ID is integer. Now we talk about foreign key. So now, if you remember, we said that branch table has, every branch has a supervisor or a manager, right? And now that manager is nothing but an employee. That employee sits in another table. So we create another table for branch. We say branch ID is an integer and call this a primary key. Branch name is a varchar. It will not be more than 40 characters. I also want manager ID, which is integer, right? And then I want manager start date. So when did a person become a manager of this? And then I want a foreign key. So I want this manager ID that I have created to be the foreign key, right? And this foreign key should reference the employee table. I'm saying that this foreign key needs to come from employee table, right? It needs to come from the employee table, and this needs to be the employee ID. So this employee ID is the primary key of the employee table, right? And now I'm just saying that this manager ID is an employee that belongs to employee table, that belongs to employee table. And on delete set null, this is something that we'll talk about later, because we have on delete set null, and we also have on delete set cascade. So on delete set null is, so for example, let's say if I delete this manager from the employee primary table, this foreign key has to be set null, right? Because now this employee does not exist anymore in the database, right? So how is going to reference it? It can't, because it does not exist. So if such thing happens, an employee ID, let's say one called Johnny, is deleted from the employee table, you need to make this manager ID null in the branch table. I hope that makes sense. And then I created the client table as well. So it, again, in client table, I have added the branch ID, which you just saw in that picture that I was showing you. Then we have works with. So works with basically tells, you see, there's an employee, there's a client, this total sales. So what I'm trying to understand here is that an employee works for which client and how many sales are they generating. So that's why it's called works with. Let's say Johnny works for a client Mercedes Benz and is generating 10 million sales per month, for example. And similarly, we have used the same concept, and we have employed the foreign keys. So that, and then we have added some value. So I just did that, all of that we already did it for the student database, so we didn't really have to repeat the same process, because you won't be learning anything new in this. So now I have added all the values. Now let's get on to it and let's start working on some queries, right? So I'll just work on some basic queries. So let's say we have, let's just see all the tables, right? So I'll just select hmm, from employee. What do we have in employee? Let's just see high level. So this is what we have in employee. In fact, this is who we have in employee. So we have all, you can see we have 9 records in employee, right? We have David, we have all these people, we have all their values. So this is what we have for employees. Similarly, we could see it's the same for all the tables. So let's say I want to see for, look at branch. We have corporate, we have Scranton, we have Stamford, we have Buffalo. This is something I had also added just to prove a point for joins. So this is what you have to do. You can start. So then what we'll do is we'll just move on, and we'll just try to uh, see how we can crunch the data out of the database. Now this collection of tables. It's a relational database that we have created. I have created, but we also have created that together. So let's say what I want to do is I want to see all clients, or let's say I want to see all employees. This is what you do for that. You want to see all the branches. This is what you do for that. But what do you want to see? We only want to see the branch name, right? So what you can do is you can just say branch name from branch. You don't want the entire table. You only want to see one column. So you identify and define that column over here, and then you just run the query. So this is what you can do. Now what I want to do is I want to see all the employees, but ordered by their salary. So I want to see which employee has the highest salary. So what I'll do is I'll select from employee order by. It means just arrange by order by salary. Which what's that column called? It's called salary, and in descending order, right? So now if you look at this over here, person with the highest salary, David, is at the top, and then in the second we have Jan, then we have Josh. So it's now arranged in descending order of the salaries. Similarly, let's say you want to see all the you want to see only first five employees from the table, right? So what I'll do is let me just copy paste this. I'm very lazy. I want to see only first five employees. So what else is I'll say, hey, show me all the employees. Show me all the records with all the fields from the employee table, but limit the result to only five. Don't show me more than five records from the employee table. Now you see, we only see five, right? Because that's what I've told the engine to do. Then I also want to see, let's say, I wanna, what else can I see? Okay, yeah. I just want to see their first names and their last names, right? I don't want to see anything else. How would you do that? Select first name, last name from employee. So now you can see I've defined two fields. I don't want to see everything from employee, right? I don't want to see everything from employee. I just want to see first name and last name of the people. So just show me that, and this is what it is doing, showing you only the first name and the last name. Now you see here it says first name underscore last name underscore. For let me zoom in. You can see here, right? It says first name. It's just giving you the column name as it is. However, if you want to change this column name in your result, not in the table, but in your result, so there's a thing we call alias, right? So alias is basically when you define how you want to show this name in your result. So I'd say call this forename and call last name as surname. Just see the magic now. Look at this place carefully. First name and last name. Now I'm saying when you give me the result, show the column of first name by the name of forename and show the column of last name by the name of surname. Press enter and you see forename and last name and surname, right? This is called aliases. This really helps you when you want to create a very good table and you know in your database your tables are named in a very weird way. So sometimes it's called, let's say, uh, product into quantity, for example, but you know that's sales, right? So you can just say that, okay, call this column sales in my results. It's easier for me to understand what my data is saying. Now there's one more thing, very important thing. So you want to see, well, I don't know what I'm about to say right now because I'm going to say something really stupid, but let's say you want to see all the unique genders. Sensitive topic, I know. I don't care. So you want to see all the unique genders in this table, right? So how many genders exist in this table? So let's say you use the term which is called distinct. You're saying, hey, show me only the distinct genders from employee table. Don't show me all the records. I just want to see what are the unique genders or sex that I have in my employee table. So it says, hey, you only have male and you only have female. You could also see, let's say, distinct names, or how many Johns do you have, or how many instances of John do you have, for example. So this distinct lets you this shows you only the unique records for any particular field, right? Okay, now you tell me that, hey, let's make it a little bit complex, or maybe let's add some more conditions. So you want to see all the employees who are females, right, and who work on a specific branch, and who have a salary which is higher than a specific number. So let's say, you just speak out with me, all right? I'll write slow so you can also think. Was there? I said select all, right? Select everything from employee table where sex is equal to female, right? All the females, and their, let's say, branch ID is 2. Branch ID is equal to 2, and their salary, and was it called salary, is greater than, let's say, 10,000. So there's only, now you see, now I've added 3 different conditions that only show me the records in the employee table with their females, and they're in the branch too, and their salary is greater than 10,000. So if you look at this and zoom in over here, you can see that there's Angela Martin, there's Kelly Kapoor. They're females, they're both in the branch ID too, and both their salaries are greater than $10,000 or whatever that unit is. I never defined the unit. So this is what we have, right? And this is how this works. So you can add as many conditions. You can also add, let's say, and their, and their birthday, right? So they're older than a specific age, or they're younger than a specific age. You can add that condition as well. Birthday greater than or smaller than the day that you want to have, or the greater than the day that you want to have. So you only want to have old employees or young employees. By old, I mean, older. Old might be offensive to some people. And then you also want to have, okay, fine, I want to have people whose salaries are between, so let's say, 55 and 63. Now we know that there is no person whose salary is between 55 and 63,000. There's no such woman, right? A woman in our table. So what I'll say is, hey, show me the woman whose salary is greater than 64,000 and salary is less than 55,000. What should it show? What do you think it should be the answer? Be null. Nothing. Because there's no one in the table that has salary more than 64,000 or less than. There's someone who has equal to 64,000, and sorry, my bad. Was it 64? Was it 63? Oh, sorry. So sorry. Or, yeah, so I'll just make 63. Yep. And now see, this is some, even anyone can go wrong. What is different between or and and? And would mean that all these conditions have to be satisfied, right? So it should be female and should be from branch ID 2, and salary should be greater than this. Or your salary could be greater than this, or smaller, or less than this. So this is a must have. This is a must have. And in this, it could be either of these two conditions, because these two conditions cannot exist together, right? If I say and, there can be no person in the world who has two salary brackets at the same time. I can't have 63,000 monthly salary and at the same time 55,000 monthly salary, right? I hope that makes sense. So that's where we use these logical operators. So this or, this and, this not, and all of these things. Then I think, yeah, this and see, you can experiment with this. You can say select all the employees whose name are John and David and Dave and Adam. You only want the data for these employees. You can add this condition as well. So you have a lot of options to just try this and work with this. I will not get into that details because, well, that's practice that you require, right? Now let's talk about aggregate functions. So what are aggregate functions, or let's say functions as a whole, right? What are they? So let's say someone just commented that it's repeating itself. Am I repeating myself, or is the video repeating itself? I'm not sure what is repeating where. Let me just read that. Yeah, I hope you guys can hear me, because I can't look at the comments and also guide this video. So now we'll talk about functions. Let's say you want to see how many employees do you have in the table? That's you all you want to see. So you'll use the function called count. Count for me. What's the ID called? Well, I just forgot. It's imp ID. Yeah. Count for me employee ID from employee table. Right. So count for me how many employees are there in the employee ID. So it tells me you have 9 employees. You can see you have 9 employees. Now, I was talking about aliases. What the hell just happened? I was talking about aliases. This looks so weird. Count emp ID. So, I mean, it's not very good to read. So you can always use aliases over here. And I say, hey, count employee ID and show that to me as total employees. Now you see here it's in total employees. Now it's very important to mention that you can't have space in between this. It has to be a single word. So you have to add some underscore. And if you want to have space in between, so you have to add this quotation on both sides, right? Or if you don't want to have add that, you have to have an underscore. So this is how you can basically use aliases and you can see the total number of your employees. And let's say you want to see what's the average salary like what's the median salary in my database. So you use the function called average. You want to have average of what? Average of salary from what table? From employee table. And just you press control enter and you see, you know what, I hate this. It's average salary. Yeah. So now you can see over here, right? So it's giving you the average of all the salaries. Similarly, you want to have the sum of all salaries. So you can just go select. You can use the function called sum salary as let's say combined salaries. See, it's just not case sensitive. So you can use the capital one. You can use the lowercase letters. Is fine. From which table? From employee table. Here you go. Now this is all the salaries combined. It's $836,000 or dirhams or rupees. Then I want to see. Well, how about tell me how many females are there and how many males are there? I want to see that in my table. So what you do, you select. When I say how many, what should come into your mind? Count, right? Select count. Count of what? Count of sex. It's zero, of course. And also show me the sex. I mean, that sounds so wrong. Also show me the gender. So now, what I want to see is now in this case you can see you're only returning one column, one result which is combined salaries because you said only show me this, right? You can choose to show as many columns as you can from a table. So I could say show me sum of salaries and then show me XYZ and everything, or you can just use this as static and it will show you each and everything, right? There's two options always. You either use a static to show the entire table or you define the columns that you want to see. So now I define that I want to see the count of the genders and I also want to see the gender. So I'll just do that. All right. From employee. Now you'll see one thing that this is something new. I have now it will give an error. Let me run this. Saying that what's it saying? I can't read. In aggregated query without group by, right? I won't read the rest. This is what I wanted to just tell you. So whenever you have aggregates, by aggregates I mean whenever you have counts or sums or averages or mix, min, max, anything, and then you also why did this not give an error before? So when you have these averages, but you also want to categorize that, you want to categorize these aggregation by an existing field in that table. You have to group it by something, right? So I am saying show me count of gender and also show me the gender from employee table and group it by gender, right? So show me these numbers but group it by gender. So I'll just say as total. I'll just run this. Are you kidding me? This sounds so bad. Group by. Sorry. I swear that was unintentional. Don't blame me for that. So we have a total of 6 males and 3 females. And you're like, it's so weird, man. Why do you have totals first and the gender second? So all you need to do is just take this, start with this as total. So now you'll have, are you kidding me? Yeah. So now you have the values before, the categories before, and values after that. So you can always decide what how to arrange these columns. So all you have to do is write the columns in a way you want them to be arranged, and that's it, right? So it's very simple. So you can apply all these different conditions, but remember, every time you're using an aggregate function and you're also using another descriptive field from that table, you need to group them by. So if I'm also using, I mean, there's not much I can, nothing else that I can use. But let's say if I had to use the first name as well, right? Now it will again give an error. I mean, using first name doesn't make sense over here, but because that will be unique. But see, it will give me an error again. It's the same error. So now you have to group it by first name. Just first group them by their sex, and then group them by their first names. And now this is fine. So if you were to show 10 more fields over here, right, you have to group them by each and everything in an order. So first group it by their genders, then their first names, and then their last names. But if you don't do that, SQL will always give you an error. So just make sure whenever you have aggregates and some other descriptive field, you group it by non-aggregate fields. So these are non-aggregate fields. This is aggregate field, and you're grouping it by. I hope this is making sense. Now let's say one last let's say one more aggregate function. You want to see the total sales of each and every employee or each and every salesman, right? So what I'll do is I'll select, let's say, sum, right? Or sum. Ah man, what is sum? I want to see total sales, right? And employee ID, of course. From, if you remember, we showed you in which table do we have the sales is only in the work with table, works with, and then group it by, right? What do you want to group it by? Client ID. I want to see now before, I mean, you might be confused here, so let me just make it easier for you and just show you what, show me, select from, works with, what this table really is. This table has an employee ID, it has a client ID, and total sales for that client. Now, one employee can work for multiple clients. You see 102 employee ID and 5, they're working for multiple clients, and you want to see their total sales for each and every client. So this is what you're going to do over here, and I'll just run this. What just happened? Employee ID from works with group by client ID. There's nothing wrong with this. Ah, I must be, I must be thinking something. Yeah. Now you see, you can see that this employee, I now why it was wrong, because I'm grouping by something. I think no, actually no, I'll turn this into a lesson. This does not work. Why? I'm saying group it by client ID, but how can it group it by something that's not even part of my select statement? How can it group by client ID when client ID will not even be returned, right? So it has to be employee ID, and when it's done, you can see for each and every employee, you can see their total sales, right? It's an aggregate of sales. And again, try to use aliases as much as you can. So total sales as sales. Just run that. Again, same error, employee ID. And here you go. Sales for each employee, or you can also see, you can say employee ID as ID, for example. I just run this. See over here. Right, so this is what we have for excuse me, for aggregate functions. Then let's just talk about joins. Oh no, wait. I think I'm just jumping ahead. Let's talk about union. We never discussed union in the lectures, I just realized. So now Difference between joins and unions, what is it? We talk that joins take data from here and some data from other table and they try to combine that. What does a union do? Union, and no, actually I did teach this. I taught this in my Power BI lesson. I just remembered. So what union does is it appends the table from top to bottom. So let's say you have, what do I pick up? Yeah. So you have one table, then you have another table. I just realized that I have been making so many gestures and there was no video. I'm drunk. So let's you have two tables, right? You have one table. It's a broken phone. You have another table. So when you're talking about joining them, so you take some data from this table, you take some data from this table, you join them, right? But when you say union, so you take some row from column from this table and one column from this table and you combine them. So it increases the rows. So just understand this concept. When you're saying joins, it will have the same number of rows depending on the condition. It will add some extra columns, right? Some extra columns from another row. But when you're saying union, union is basically joining that and appending that to the bottom of the table. So let's just look at an example over here. Let's say what I want to say is I want to have a list of all the employees, like the name of all the employees and the name of all the branches just in one good column. How would I do that? So I'd say no, no, just notice here what I'm going to do. So now employee dot first name. Now why did I add this? I never added this before. I always said that hey, only take first name from employee, sex from employee, last name from employee. Now I'm saying select employees. First I'm writing the name of the table and then the field. Why is that so? It is because now we're talking about two different tables. Now, both of these tables could have had the same field name. So let's say first name. How would SQL or DBMS know that which table specifically I'm talking about? So you have to specify that, hey, select first name from the employee table, right, as, let's call it employee hmm, branch name. From employees. Now you might say, hey, what the hell is happening? You might say, why are we even using this over here? Because when we're writing employee over here, I'll say that I'll let you know of that in the joins topic when you're talking about joins. Why do we have to mention employee here when we're explicitly telling it's the employee table? I'll tell you why. So now we say, hey, select this. So I'll tell you what the result is going to be. This is the result of just one table, right? It's all the nine name of the employees. But what we said was we also want to have employee names and under that we want to have the branch names. So what I'll do is I'll use the function of union. Now union this result that we just have gotten with with the branch name. So branch name belongs to which table? It belongs to branch, right? Dot the field name, branch name from branch. Now you see, let me zoom in. So we have all these nine names, but we also have the branches under that. So we said, hey, select the employee name from employees. So we have all the employees. And then I said, combine that with this. So what do I mean by this? Let's say I only run this. So I say, hey, there's this one query, that's the branch names. Then there's this another query, that's the employee's name. We have two queries, we have two results. Please combine that for me. And then you run this. You see, here it has combined all of those for you. Now you can, now this is a very basic example, but because this table is this database is very simple. But let's say, what's the application of this? Let's say three different tables in your database. You have sales for 2015, you have sales for 2016, for 2017, three different tables. Now for your analysis, you just want to have one single table, right? Why do you need three? In that case, you will use union to join these three, to combine these three tables into one big table. That will be a sales table. So this is the kind of applications that you can use when it comes to joins and unions. Now we talk about joins. So what is a join? We already said we have different kind of joins, right? So now let's say you want to know that, let's say you want to know branch, you want to know the branch of the employee, but you want to know the branch by the branch name. So far all we had is, let me just write select from uh, employee. See, we know their branch ID, but we want to see their branch name. So I just want to see the first name of a person, and I want to see their branch ID, branch name. That's it. So what I'm going to do is, I'm going to write a query that select. First, what I do is I write the table name, employee ID, right? Employee dot first name, and then branch. Now I want to see their ID, their first name, and then I want to see the branch name. So I choose the table branch dot the field that I want to see. What is that field? That's branch name. Now in the previous step I said why am I mentioning employee over here when I am explicitly saying from employee. In joins, you see how it's different. I'm mentioning employee. I yet have not mentioned the from clause. I'm saying select employee ID from the employee table, select first name from the employee table, and show me the branch name as well from the branch table. And then I'll say from employee, right? So show me these things from the employee table, show me this from the employee table, show me this from the employee table. But I also want to see this, but now it does not exist in the employee table, right? So how would the engine know where to get this data from? So I'll say, hey, select these two from me for me from the employee table and join, or let's say left join it on which table. So I'm which two tables am I combining? So I'm combining employee table with the branch table, right? I'm saying, hey, combine the employee table with the branch table, use the left join. And what to combine on? So we always said when we are combining two tables, there's one thing very important. That's something common between them. What's common between these two tables in this case? It's is their IDs, right? So we talked about having their so it's in branch table we have the manager ID. If you remember, in branch table we have manager ID. Let me just show that to you real quick. So select from branch. So in branch table, you see we have manager ID, which is basically employee ID, and employee table, we already have employee ID. So I'm saying left, make a join between these two tables on what common field? The common field is employee imp ID. What is this common with? This is common with branch dot. So I'm saying, hey, just look at this carefully. Yeah, I'm saying join the table employee with the table branch. And what is the common identifier between them? What is something common between them that's in both the tables? That the employee ID. So it's called employee ID in the employee table and is the manager ID in the branch table. And give me the result. So what left join will do is it will show you all the employee IDs, whether or not they are a manager of the branch, and it will show you branch names for all the employees. So just check this out. Now you see left join, just look at this carefully. Left table, which is the left table? This is a left table, right? So when we say left table, the first table that we have mentioned is the left table, and this is the right table or the second table. So if you look at this, we all, how many employees did we have? We had 9 employees, but we only had 4 branches. So and one branch had no manager, so that's why it's not here. Or you know what, let's just say we only had 3 branches, right? So why is it showing 9 instead of only 3? But because we're combining them, right? But we decided that It's a left join, which means show me all the employees, each and every employee from the employee table, which is the first table, but only matching records from the right table, which is the branch table. So David belongs to, he's the manager of corporate branch. Michael is manager of Scranton branch. Josh is manager of Stamford branch. Why these nulls? Of course, if you think logically, no branch can have two managers. So, but what if you only want to see the managers? You don't want to see everyone else. You don't want to see Jan or Angela or Kelly or Stanley because they're not managers. You only want to see managers. What you do is just remove this. Either you say inner join or you just don't use the word. You just say join. It will already it will be considered as an inner join. And now you see it's only giving you the common ones from both the tables. So it's only giving you wherever there is a common employee ID and manager ID. So if you have an employee ID and a manager ID in both the tables and they exist, it will only give you those results. And if you could also then try to do the right join. Now what will happen in right join? Just take a moment to think. Everything from the right table, which is the branch table, only matching records from the left table, which is the employee table. So I just press Control Enter. You see there's going to be one extra thing, which is the Buffalo branch. Now I said Buffalo branch does not have a manager. A manager is not assigned to it. But since I said right join, whether or not a branch has a manager, I don't care. Give me everything from the right table, which is the branch table, each and every branch, and only give me the matching records from the left table. So by matching, we mean this. This is the condition that means matching. So this condition basically matches the two tables, right? It will look at the employee ID in the first table and try to find the same employee ID in the second table. So you're telling it, you're defining it that hey, try use this employee ID and manager ID to match the records. So it when it tried matching, it could not find anything for the Buffalo because in the Buffalo branch, manager does not exist. So this is the concept of join. So when you have a lot of tables, let's say you have a product table, you have a sales table, you have a let's say address table, you have a shipping detail table, customer table, and you want to join all that information into one place, right? You want to see what customer bought what products and where were they shipped, right? And what was the revenue or what was the price of that. So in such cases you join some information from one table and then some from another table and then some from third table to give you a holistic view. It really helps in your analysis. So if you really want to understand data as a whole, of how your data is performing, right, of how of maybe trying to get into analytics, get some cool results, you always need to know how to use joins. I think that's pretty much it for today because I think you first need to practice these. You need to practice unions and joins and constraints and these aggregate or mathematical functions. Once you have experience on this, once you have done some practice, then you move towards nested queries. We move towards some triggers, some stored procedures, and then you're good to go. So what I'd like you to do now is just practice these and get prepared for the next session because what I have plans is for the next session we'll go into part 3. I will not talk about theory at all. The entire 1 hour session will be only and only SQL. I will not do any recap because some people who attend these sessions back to back, I feel it might be good for them for revision, but I believe most of them just come to do hands-on practice. So we're going to talk about SQL part 3 in the next session, and it's going to be quite interesting. We'll talk some detailed concepts and we'll do some detailed queries and some complex queries. And I think that's it for this session. So thank you so much again for joining. I really appreciate your time. I appreciate actually, yeah, I do appreciate your time. But thank you so much, and I hope this was useful. I hope you learned something out of it, and I hope you actually practice because without practice, this is just another video that you watched, which will not really help you. So I'll look. God, man, I think when I speak more than an hour, I just lose the plot. So I'll see you guys again in the next session, and I'll share the details of all these queries with you in the WhatsApp community and on my profile, so you can go and practice. So if you have any questions, please write them down in the comments, and I'll answer that. Take care and bye.